The morning of March 4th, 1944. 26,000 feet above the frozen German countryside, Hauptmann Heinz Knocke banked his Messerschmitt 109 into position, scanning the sky through his gunsicht optical reflector sight. A veteran fighter pilot with over 400 combat missions, Knocke knew every corner of Reich airspace, every altitude where American bombers cruised, every point where their escort fighters traditionally turned back. Today would be different. Today's target was Berlin itself, over 1,100 miles round trip from English bases. The mathematics were simple, the conclusions certain. No single-engine fighter could reach the German capital and return. The Americans would fly alone into the teeth of the Luftwaffe's defense, just as they had over Schweinfurt 4 months earlier, when 60 B-51s never came home. Knocke's wingman crackled over the radio, reporting contrails ahead. The bomber stream. Massive formations of fortresses and liberators, their aluminum skin catching the morning sun as they droned eastward toward Berlin. Standard procedure dictated patience. Wait for the American P-47s to reach their fuel limit and peel away, then attack. The Thunderbolts typically escorted perhaps 300 miles into German territory before fuel constraints forced them home. After that, the bombers belonged to the Jagdwaffe. But something was wrong today. The contrails weren't just heavy bombers. Knocke's experienced eye caught the distinctive patterns of fighter aircraft weaving above the formations. At this distance, well past where the escorts should have turned back, American fighters were still with the bombers. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Knocke reported the sighting to ground control. The response was immediate and dismissive. Impossible. Those must be twin-engine, P-38s, known to have extended range, though still insufficient for Berlin. Single-engine fighters lack the fuel capacity for such distance. But Knocke was staring directly at them. Not the twin-boom silhouette of Lightnings. These were single-engine aircraft, sleek, fast, and dangerously close to the bombers. He pushed his throttle forward, closing the distance to identify the intruders. At 3,000 feet separation, recognition came with the force of physical impact. P-51 Mustangs. American single-engine fighters. Over Germany's heartland. 560 miles from their bases in England. The technical impossibility of what Knocke was witnessing would cascade through Luftwaffe intelligence offices within hours. For months, German fighter tactics had been predicated on a simple fact verified by captured aircraft analysis and fuel consumption calculations. American single-engine fighters could not escort bombers to Berlin. The P-47 Thunderbolt, despite its rugged construction and 850 caliber machine guns, had operational range of perhaps 600 miles with external tanks. The P-38 Lightning, twin-engine and theoretically longer-ranged, struggled in European conditions and remained in short supply. Neither aircraft could provide continuous escort to targets deep in the Reich. German defensive doctrine evolved around this limitation. Allow escorts to accompany bombers part way, wait for fuel to force the fighters home, then attack the undefended formations with concentrated force. This strategy had worked devastatingly well through 1943. The raid on Schweinfurt in October of that year exemplified the brutal effectiveness of this approach. 291 B-17s attacked ball-bearing plants critical to German war production. Without fighter escort for the final leg, 60 bombers were destroyed. Another 17 damaged beyond repair, 600 American airmen dead or missing. Loss rates exceeding 20% made completing a required 25-mission tour statistically unlikely for bomber crews. The psychological toll was immense. Men calculated their odds each morning, knowing that flying deep into Germany without escort meant facing hundreds of German fighters that could attack with impunity. German intelligence studied every captured American fighter with systematic thoroughness. At Rechlin-Lehr's airfield in Mecklenburg, the Luftwaffe's primary aircraft testing facility, teams of engineers measured fuel capacity, tested performance at various altitudes, calculated range at different power settings. The P-47 Thunderbolt captured near Aachen in August 1943, provided comprehensive data. Internal fuel capacity, 370 gallons. Fuel consumption at cruise power, roughly 70 gallons per hour. Maximum internal fuel endurance, approximately 5 hours. At cruising speed of 280 miles per crew hour, theoretical maximum range 1100 miles. But this calculation assumed flying in one direction until fuel exhaustion. Combat operations required reserve fuel for maneuvering, engagement, and return flight. Practical combat radius was therefore approximately half the maximum range. The P-47 could escort bombers roughly 300 miles from base, fight for perhaps 15 minutes, and return home. This matched perfectly with observed behavior in combat. American Thunderbolts appeared over western Germany, engaged briefly, then disappeared back toward England. The mathematics confirmed what battlefield observation demonstrated. Single-engine fighters could not reach Berlin. The P-38 Lightning presented a theoretically different profile. Twin Allison engines gave extended range potential, and its turbocharged engines performed well at altitude. Intelligence estimates suggested the Lightning might reach 500 miles with external tanks. Perhaps enough for targets like Brunswick or Hanover, but Berlin remained beyond reach. Additionally, the Lightning suffered mechanical problems in European weather. Cold temperatures caused engine failures. Compressibility issues plagued high-speed dives. American P-38 units remained relatively small in number, focused primarily on Mediterranean operations, where the aircraft performed better in warmer conditions. By early 1944, Luftwaffe operational planning incorporated these range limitations as fundamental constants. Defensive fighter units positioned themselves across Germany, knowing with certainty that beyond approximately 300 miles from England, bombers would be unescorted. Jagdgeschwader commanders scheduled their formations to intercept at points where American escorts had departed. The tactics proved devastatingly effective through late 1943. Then came March 4, 1944. The American raid on Berlin that morning included approximately 150 B-17s. Weather problems scattered the formations and limited the bombing effectiveness. But the strategic significance had nothing to do with bombs dropped or damage inflicted. The significance was the presence of American single-engine fighters over the German capital. P-51 Mustangs from the 354th Fighter Group, recently transitioned from P-47s, escorted the bombers all the way to Berlin, fought German interceptors over the target, and returned to England. 2 days later, on March 6th, over 600 heavy bombers struck Berlin with escort coverage throughout the mission. Over 800 fighters provided protection, including approximately 150 Mustangs. Luftwaffe pilots reported engagements with P-51s over Berlin itself. American fighters were operating at full combat capability over the German capital, 560 miles from their bases. The intelligence crisis, this created reverberated through the Reich Luftfahrt Ministerium, the Reich Air Ministry. Technical officers scrambled to explain the impossible. How were American fighters reaching Berlin? The P-51 had been known to Luftwaffe intelligence since 1943. Early versions with Allison engines performed well at low altitude but struggled above 20,000 feet where bombers cruised. The Merlin-engined P-51B variant had been evaluated from captured examples, but range assessments remained incomplete. Initial analysis suggested the Mustang had good range, perhaps better than the Thunderbolt, but still insufficient for Berlin missions. The March missions shattered these assessments. General Major Adolf Galland, General der Jagdflieger and commander of all Luftwaffe fighter forces, had been flying combat missions during the Berlin raids despite his administrative role. An ace with over 100 victories, Galland possessed the combat experience to immediately recognize tactical realities. He encountered P-51 formations over Germany and understood instantly what their presence meant. These were not fighters at the limit of their range, desperately conserving fuel for the return journey. They engaged aggressively, pursued German fighters in extended dogfights, fought at full combat power with no apparent fuel restrictions. The Mustangs had reserves, substantial reserves. This contradicted everything Luftwaffe intelligence believed about American fighter capabilities. Gallen's combat reports submitted through official channels noted the P-51's superior performance at high altitude. The Mustang was faster than the Bf-109 above 20,000 feet and more maneuverable than the W-190 at altitude where four-engine bombers operated. American fighters were no longer inferior to German aircraft in the performance envelope that mattered most for bomber escort. Combined with range that now reached anywhere in the Reich, the P-51 represented a strategic threat of existential proportion. German fighters could no longer attack bomber formations unopposed after Allied escorts turned back. Every intercept now required fighting through fighter screens. Loss rates, already climbing through late 1943, would become catastrophic. The technical evaluation teams at Rechlin focused urgently on determining how the Americans had achieved such range. A relatively intact P-51B had been recovered near Brandenburg following the March 6 mission. The pilot had not survived, but the airframe remained structurally sound, providing German engineers their most complete Mustang example yet. The navigation charts, still in the cockpit, showed the route from Debden in England to Berlin and return. Total distance 1,120 miles. Technical staff began systematic analysis. The P-51B featured 2 wing fuel tanks, each holding 92 gallons. The fuselage contained an 85-gallon tank positioned directly behind the cockpit. This fuselage tank was a relatively recent modification incorporated during production to extend range. Total internal fuel capacity was 269 gallons. The Packard-built Merlin engine was a licensed version of the Rolls-Royce Merlin that transformed the Mustang's high-altitude performance. At economy cruise settings, the engine consumed approximately 60 gallons per hour. At normal cruise power, consumption increased to 75 gallons per hour. In combat, with throttle advanced to war emergency power, consumption exceeded 100 gallons per hour. German engineers performed range calculations using these figures. With 269 gallons internal fuel and consumption of 70 gallons per hour at cruise, the P-51B could fly approximately 3.8 hours. At cruising speed of 300 miles per hour, maximum range was 1,140 miles, precisely enough to reach Berlin from English bases and return, but barely, with no reserves for combat operations. Yet combat reports clearly indicated American fighters engaged in prolonged dogfights over Berlin, sometimes lasting 15 to 20 minutes before disengaging. Combat power settings consumed fuel at rates exceeding 100 gallons per hour. Such expenditure should have left aircraft unable to complete the return journey. The calculations did not explain observed combat behavior. The answer became apparent when technical staff examined the aircraft's wing structure more carefully. The P-51B featured standardized hardpoints under each wing designed to accommodate external stores. These attachment points included fuel line connections, indicating specific design for external fuel tanks. Drop tanks were not revolutionary. German fighters had employed them since the Battle of Britain. The Bf-109 could carry a 300-litre drop tank. The FAF-W-190 regularly used them for extended range missions. The question was not whether Americans were using drop tanks. The question was capacity and production scale. Intelligence officers plotted likely jettison points based on engagement locations reported by Luftwaffe pilots. Drop tanks would typically be released when enemy fighters were encountered, as external stores reduced maneuverability and speed. Search teams composed of Wehrmacht personnel and Hitler Youth volunteers spread across the countryside northeast of Berlin, looking for debris from the air battles. Within 3 days, several objects were recovered from fields and forests. Most were fragmentary, crushed on impact or damaged by the fall. But 2 examples arrived at Rechlin in relatively intact condition, having landed in soft soil that cushioned impact. The captured drop tanks revolutionized German understanding of American industrial capability in ways that transcended mere technical analysis. The tanks were cylindrical, measuring approximately 108 inches in length, with diameter of roughly 22 inches at the widest point. Capacity calculations indicated each tank held approximately 108 U.S. gallons. Two such tanks provided 216 additional gallons, extending the P-51's total fuel capacity to 485 gallons. With this fuel load, the Mustang could fly approximately 6.7 hours at cruise power, yielding range exceeding 2,000 miles, more than sufficient for Berlin missions with substantial combat reserves. The fuel capacity mathematics finally made sense, but what immediately captured the attention of German engineers was not the tank's capacity, it was their construction. The drop tanks were not made of metal. Running a hand along the surface revealed texture, unlike aluminum or steel. Silver paint coating the exterior could not disguise the fundamental nature of the material beneath. When engineers carefully scraped away paint near the tail cone, they found multiple layers of heavy paper, each perhaps 0.5 millimeter thick, compressed and laminated together with resinous adhesive. The construction was sophisticated and purposeful, not improvised. The nose cone and tail cone were formed from overlapping pieces pressed into shape. The center section was seamless, wrapped around a cylindrical form in continuous layers. Fuel fittings were brass, precisely machined and properly sealed. Peering through the filler cap revealed an interior coated with cellulose-based lacquer designed to resist the corrosive effects of aviation gasoline. Materials specialists brought in to analyze the tank's construction identified the paper as kraft paper, manufactured using chemical pulping processes, producing exceptionally strong cellulose fibers. This was material used for heavy-duty shipping containers and industrial packaging. The adhesive was phenol formaldehyde resin, a thermosetting polymer, creating bonds stronger than the paper itself when heat-cured. Lamination involved at least 12 separate layers, each oriented to provide strength in multiple directions. Anti-slosh baffles made of wood prevented fuel from surging during maneuvers. The entire construction process was clearly standardized, designed for mass production. Most significantly, the empty tank weighed approximately 80 pounds, comparable to metal tanks of smaller capacity. The paper construction was not significantly lighter than metal, but offered different advantages that German engineers immediately recognized. The implications were stark and psychologically devastating to technical staff understanding what the tanks represented. The Americans were manufacturing fuel tanks from non-strategic materials. Paper and wood-based resins did not require aluminum, steel, or other metals, increasingly scarce in wartime economies. Manufacturing required no specialized metalwork equipment, no skilled metal workers, no welding or forming of sheet metal. These tanks could be produced in any paper mill or packaging factory with relatively simple modifications. The United States had hundreds of such facilities. If even a small percentage of American paper production had been converted to drop tank manufacturing, output could reach thousands of units per week. The tanks appeared to have no serial numbers, no manufacturer markings, nothing indicating limited production. They were commodity items, mass-produced and completely expendable. Intelligence officers began researching American paper industry capacity. The United States produced approximately 12 million tons of paper annually before the war, with production increasing during mobilization. Converting even 1% of this capacity to drop tank production would yield over 100,000 tanks per month, far exceeding any plausible requirement. The real constraint would be manufacturing equipment and labor, but this was precisely the type of production that could be performed by semi-skilled workers after minimal training. The paper tanks represented industrial efficiency and resource optimization on a scale German planners found difficult to comprehend. Further analysis revealed additional details about design and use. The tanks were strictly single-use items. The phenolic adhesive, while creating strong bonds when cured, slowly dissolved with prolonged contact with aviation gasoline. Intelligence reports and interrogation of captured aircrews indicated paper tanks had to be filled immediately before flight and could not be stored filled for more than a few hours without developing leaks. This limitation did not affect operational use. Fighters were fueled during pre-flight preparation. Tanks would be used for a few hours during missions, then jettisoned. The single-use nature actually simplified logistics. No need to recover and reuse tanks. No need for cleaning, inspection, maintenance. They were expendable by design. The color coding provided another detail reflecting systematic engineering. Paper drop tanks were painted silver, while metal tanks were grey. This distinction allowed ground crews to quickly identify tank types during fueling operations. The silver finish on paper tanks also helped reflect solar heat, reducing fuel evaporation and vapor pressure issues at altitude. Every aspect reflected optimization for mass production and field use. By late March 1944, German intelligence traced the paper tank's origin to British development. The Air Ministry in London had commissioned development of impregnated paper fuel tanks in 1943 to conserve strategic metals, particularly aluminum. The Escort Corporation, utilizing expertise in paper manufacturing, developed the production process. Tanks entered service with RAF fighter squadrons in late 1943. American forces quickly adopted the design, with multiple manufacturers in Britain and the United States producing tanks for use by 8th Air Force fighter groups. The innovation had been driven by British resource scarcity, but was being exploited on massive scale by American industrial capacity. The broader implications extended far beyond fuel tanks. German technical staff began systematic review of captured American equipment, looking for other examples of industrial innovation and mass production techniques. The results painted a consistent picture. American equipment was not always technologically superior to German equivalents in individual component performance. German optics were often better. German small arms were often more sophisticated in design. German armor metallurgy was in some respects more advanced, but American equipment was consistently better manufactured, more standardized, more reliable, and available in vastly greater quantities. The American approach prioritized producibility over perfection. Components were designed from the outset for mass production by semi-skilled workers using standardized tooling. Parts were interchangeable between units without hand-fitting. Assembly line methods reduced production time and increased output. The contrast with German production methods was stark. German weapons and equipment were often technical masterpieces, hand-fitted by skilled craftsmen. A German tank or aircraft engine represented the peak of precision engineering. But building such equipment required skilled labor, specialized tools, and significant time per unit. Production rates were constrained by availability of master craftsmen and precision manufacturing equipment. The Germans built superior individual items. The Americans built adequate items in overwhelming quantity. In industrial warfare, quantity had proven decisive. Analysis of P-51 Mustang production illustrated this principle. North American Aviation had designed the original Mustang prototype in response to a British requirement in 1940. The prototype was completed just 117 days after contract signing, one of the fastest design-to-prototype cycles in aviation history. First flight occurred on October 26, 1940. By 1944, North American was producing P-51 variants at 2 facilities. The Inglewood plant in California averaged approximately 364 Mustangs per month during peak production. The Dallas plant contributed additional output. Combined production across both facilities reached approximately 574 P-51s per month during 1944, with production accelerating throughout the year. Peak monthly production would reach 881 aircraft in January 1945. Each P-51 required approximately 15,000 individual parts manufactured by hundreds of subcontractors across the United States. The Packard-built Merlin engines were produced in Detroit at rates exceeding 300 units per month. Final assembly of a P-51D required approximately 22,000 man-hours of labor, but the production line system meant completed aircraft rolled out at intervals of a few hours. At peak efficiency, a new Mustang was completed approximately every 2 hours. The scale and efficiency of this production system exceeded anything Germany had achieved. Messerschmitt and Focke-Wulf combined produced approximately 600 fighters per month in early 1944. Despite operating under emergency priority programs and utilizing forced labor, German aircraft production could not match American output. The resource implications were equally sobering. American aluminum production in 1944 reached approximately 1.25 million tons, equivalent to £2.5 billion annually. This represented massive increase from pre-war production of approximately 164,000 tons in 1939. Germany's aluminum production, by contrast, peaked at approximately 250,000 tons per year and was declining due to bombing of production facilities and loss of bauxite sources. The Americans had approximately 10 times Germany's aluminum production capacity. The decision to manufacture drop tanks from paper rather than aluminum was not driven by metal scarcity. The United States had sufficient aluminum to produce every drop tank in metal if desired. Paper was chosen because it was cheaper, required less critical manufacturing equipment, freed aluminum for other uses, and could be produced more quickly with less skilled labor. This was optimization, not desperation. The psychological impact of these revelations spread through Luftwaffe technical and operational communities. The paper drop tank became a symbol of American industrial capability and the fundamental disparity in resources between combatants. Captured examples were displayed at technical briefings for Luftwaffe personnel. Pilots transitioning to fighter units were shown the tanks and asked to calculate implications for combat tactics. The message was clear. American fighters could now escort bombers anywhere in Germany. The previous defensive strategy of waiting for Allied fighters to reach fuel limits and turn back was obsolete. Luftwaffe fighters would have to engage escorts to reach bombers, and those engagements would cost aircraft and pilots at rates Germany could not sustain. Galland provided operational assessments in conferences with senior Luftwaffe leadership throughout spring 1944. The P-51 was superior to German fighters above 20,000 feet, he emphasized repeatedly. It was faster than the Bf-109 at altitude and more maneuverable than the FW-190. With extended range provided by drop tanks, it could escort bombers throughout their mission profile. German fighters could no longer attack bomber formations unopposed, after Allied escorts turned back. Every intercept now required fighting through the fighter screen. Loss rates were climbing steadily. In January 1944, the Luftwaffe lost approximately 90 fighters while claiming approximately 150 Allied aircraft destroyed. By February, German losses had increased to approximately 160 aircraft against approximately 230 Allied losses. The trend was clear and unsustainable. The Americans and British could replace losses faster than Germany could inflict them. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The summer of 1944 brought the full impact of American escort fighter capability. The 8th Air Force conducted deep penetration raids almost daily when weather permitted. Mustangs provided continuous escort from England to targets across Germany and back. Luftwaffe fighter losses mounted catastrophically. In June 1944, approximately 350-day fighters were lost, defending the Reich. In July, losses exceeded 350 single-engine fighters in the West alone, representing 31.2% monthly attrition rate. August saw similar losses with 36% attrition. At these rates, experienced pilots were being killed faster than they could be replaced. Replacement pilots arriving from training schools had perhaps 150 hours flight time compared to 300 hours or more for American pilots. Many German replacement pilots had as little as 30 hours in type before assignment to operational squadrons. The experience gap, combined with numerical inferiority and constant presence of P-51 escorts, made daylight operations over Germany increasingly deadly for the Luftwaffe. Galland submitted repeated assessments to Hitler and senior Wehrmacht leadership throughout this period. His September 1944 report stated the situation bluntly. The Luftwaffe could not win the air war. Germany lacked the resources, the fuel, the aircraft, and the trained pilots necessary to contest Allied air superiority. The Americans could replace losses faster than Germany could inflict them. Their industrial capacity was beyond Germany's ability to counter through combat operations. The only viable strategy was to husband remaining resources for defense of critical targets and hope for political settlement before complete collapse. The paper drop tanks continued to fall across Germany throughout late 1944 and into 1945. German civilians learned to recognize the distinctive cylindrical shapes lying in fields and forests. Initial reports sometimes described them as unexploded bombs, causing local panic until military authorities identified them as harmless fuel tanks. Instructions were distributed through civil defense organizations, explaining that silver cylinders falling from Allied aircraft were empty fuel tanks, not weapons. The psychological impact was noted in civilian morale reports. The sight of enemy aircraft overhead in such numbers that their contrails crisscrossed the sky, casually discarding expendable fuel tanks, reinforced the message that Allies had resources to waste while Germany scraped for every litre of fuel and every kilogram of aluminum. Technical intelligence continued analysing captured American equipment throughout 1944, but focus shifted from understanding capabilities to documenting scale of industrial disparity. Could Germany manufacture similar paper drop tanks? The technical answer was yes. German chemical industry could produce suitable resins. German paper mills could manufacture kraft paper. The manufacturing process was not particularly sophisticated, but the practical answer was no. Germany's chemical industry was already operating at maximum capacity, producing synthetic rubber, explosives, and other critical materials. Resin production for non-essential items could not be prioritized. The paper industry was fully committed to military requirements for maps, documents, and packaging. Most critically, there was no operational requirement for extended-range drop tanks. By late 1944, fuel shortages were grounding large portions of the Luftwaffe. Pilot training was reduced to minimal levels. Operational sorties were limited by fuel availability rather than aircraft availability. Building drop tanks to extend range was meaningless when there was barely enough fuel for local defensive operations. The irony was stark and bitter to German planners. The Americans had solved the fighter range problem with paper fuel tanks at exactly the time when German fighters were grounded by fuel shortages. Different problems, different industrial bases, different outcomes. The Americans had more of everything: more aircraft, more fuel, more pilots, more aluminum, more industrial capacity, and sufficient excess capacity to optimize solutions like paper drop tanks. Germany was fighting a war of scarcity against an enemy for whom scarcity was not a constraint. By January 1945, the war's outcome was beyond doubt. Soviet forces were approaching the Oder River, less than 50 miles from Berlin. Western Allied forces had recovered from the Ardennes offensive and were pushing toward the Rhine. The Luftwaffe could mount only sporadic resistance, limited by fuel availability and pilot losses. The systematic study of American equipment continued at Rechlin, but it had become an academic exercise. Findings were documented for historical record, but could no longer influence the war's outcome. The final comprehensive analysis of the P-51 and its drop tanks was prepared in late January 1945. The report documented every technical aspect of the Mustang's range capability, drop tank construction methods and materials, production estimates, and operational implications. The conclusion was unambiguous. The P-51 Mustang, equipped with expendable paper drop tanks manufactured from non-strategic materials, has rendered the German heartland indefensible against American daylight bombing. Germany lacks the industrial capacity to match American fighter production. the fuel to sustain combat operations at required scale, and the trained pilots to replace losses at current attrition rates. The report was filed in Reich Air Ministry archives in late January 1945. Whether senior leadership read it is unknown. By then, technical reports analyzing American capabilities were simply confirming what battlefield reality had already demonstrated. The Luftwaffe, which had dominated European skies in 1940, was reduced to occasional desperate sorties by early 1945, hoarding precious fuel for missions that could not change the strategic situation. American fighters roamed freely over Germany, attacking targets of opportunity, escorting bombers, establishing complete air supremacy. Each paper-drop tank falling from American aircraft was a reminder of industrial disparity that had decided the air war. The June 1944 exhibition at Rechlin had displayed captured Allied aircraft to Luftwaffe personnel, including multiple examples of the P-51 Mustang alongside B-17s and B-24 bombers, P-38 Lightnings, Lancaster bombers, Mosquito fighter bombers, Typhoon fighter bombers, and various Spitfire variants. Thousands of Luftwaffe pilots and ground personnel toured the exhibition, examining enemy equipment firsthand. The paper-drop tanks were displayed prominently, with technical diagrams explaining construction and range implications. The exhibition served as both educational tool and sobering reality check. German personnel could see the quality of Allied equipment, the standardization of components, the evidence of massive production capacity. The overwhelming scale of Allied industrial mobilization was made tangible through physical examples of equipment they faced in combat daily. Kampfgeschwader 200, the Luftwaffe unit responsible for special operations including flying captured Allied aircraft, operated several P-51s throughout 1944. These aircraft were used for evaluation flights, allowing Luftwaffe test pilots to experience firsthand the performance characteristics that made the Mustang such an effective fighter. Reports from KG-200 pilots consistently noted the P-51's excellent visibility from the cockpit, particularly in the later P-51D model with its bubble canopy. The aircraft was stable in flight, responsive to controls, and possessed excellent high-altitude performance. The Merlin engine provided smooth, reliable power throughout the operating envelope. Most significantly, the range and endurance were extraordinary for a single-engine fighter. With full internal fuel and drop tanks, the P-51 could remain airborne for over 6 hours, flying missions that would have been impossible for German single-engine fighters, even with external tanks. The technical understanding gained at Rechlin contributed to German defensive tactics in the final year of war. Recognizing that American fighters could escort bombers throughout missions, Luftwaffe fighter controllers attempted to concentrate forces at specific points to achieve local superiority. This required careful coordination and timing as dispersed German units had to assemble at designated locations to create formations large enough to have a chance against heavily escorted bomber streams. Fuel constraints and communication difficulties often prevented successful concentration. Even when German fighters achieved favorable positions, the presence of P-51 escorts made attacks on bomber formations extremely costly. The tactical situation had fundamentally shifted. In 1943, unescorted or poorly escorted bomber formations had suffered catastrophic losses. By mid-1944, German fighters attempting to reach bombers suffered the catastrophic losses. The paper-drop tanks themselves became collector's items after the war. Very few examples survived intact, as most were destroyed on impact or deliberately crushed by Allied ground crews to prevent reuse by enemy forces. The expendable nature meant they held little intrinsic value. The few that survived became museum artifacts and historical curiosities. The National Air and Space Museum in Washington maintains several examples in its collection, displayed alongside P-51 Mustang aircraft they were designed to serve. Information placards note the construction from laminated kraft paper impregnated with phenolic resin, manufacturing by companies like Bowater Scott, and capacity of 108 US gallons. The placards do not typically mention that German engineers spent weeks analyzing these tanks, calculating their implications, and understanding through them the full scale of Allied industrial superiority. The story, preserved in technical reports and post-war interviews, reveals the psychological impact on German technical personnel. They were not analyzing a superior weapon. The paper drop tank was not advanced technology. It was, in fact, a deliberately simplified design using non-critical materials. But that very simplicity carried a message more devastating than any technical sophistication could have conveyed. The Allies had such overwhelming industrial capacity that they could afford to optimize designs for mass production rather than performance. They could manufacture fuel tanks from paper because they had unlimited paper, unlimited resin, unlimited manufacturing capacity, and unlimited fuel to put in the tanks. The optimization was not driven by scarcity, but by efficiency. Germany's experienced engineers understood immediately what this meant. They were not fighting an enemy, desperately improvising with substitute materials. They were fighting an enemy so wealthy in resources that substitution was a choice made for efficiency, not a necessity imposed by shortage. Post-war interrogations of Luftwaffe personnel consistently returned to this theme. When asked when they first understood Germany would lose the war, many technical staff and senior officers cited early spring 1944 as the turning point. The arrival of long-range fighter escorts over Berlin marked a decisive shift in strategic balance. Hermann Göring, interrogated after the war, acknowledged that long-range fighters had delivered a major strategic blow to German defensive planning and were among the most decisive factors in the ultimate outcome of the air war. While specific quotes about Mustangs over Berlin remain unverified in primary sources, Göring's post-war statements consistently acknowledged that Allied air superiority, made possible by long-range escort fighters, had been decisive in Germany's defeat. The technical lessons learned by German engineers who examined captured P-51s and their drop tanks contributed to post-war aviation development. Many of these engineers immigrated to the United States or worked with Allied technical intelligence services after the war. Their detailed understanding of American production methods and design philosophy influenced their later work. The emphasis on standardization, interchangeability of parts, and design for manufacturability became standard practice in post-war aircraft development. The paper drop tank itself became a case study in wartime industrial innovation, taught in engineering schools and military staff colleges as example of how resource optimization and mass production could provide strategic advantage. The P-51 Mustang continued in service with various air forces for decades after World War II. The aircraft saw extensive combat in the Korean War, serving primarily in ground attack and close air support roles. The excellent range and endurance that made it an outstanding escort fighter in Europe proved equally valuable in the very different operating environment of Korea. P-51s remained in frontline service with some air forces into the early 1980s, testament to the soundness of basic design. More than 15,000 Mustangs were produced during and immediately after the war, making it one of the most numerous American fighters of the era. Today, over 100 P-51s remain airworthy, maintained by collectors and museums worldwide. The sight of a Mustang in flight, often still wearing distinctive markings of wartime units, serves as reminder of the aircraft's role in establishing Allied air supremacy over Europe. The broader historical significance of the P-51 and its paper drop tanks extends beyond tactical and operational impact. They represent a case study in industrial warfare and the importance of production capacity in modern conflict. World War II was decided not primarily on the battlefield, but in factories, the side that could produce more weapons, more ammunition, more aircraft, more vehicles, and more supplies faster than they were consumed in combat, held decisive advantage. The United States achieved industrial mobilization on a scale unprecedented in history. Peak wartime production in 1943 to 1944 saw American factories producing aircraft at rates exceeding 50,000 per year, ships at rates of multiple vessels per day, and ammunition in quantities measured in billions of rounds. This industrial output supported not only American forces, but also supplied substantial quantities of equipment to Britain, the Soviet Union, and other Allied nations through Lend-Lease. Germany, despite possessing significant industrial capacity and technical expertise, could not match Allied production. The reasons were multiple: smaller industrial base, strategic bombing of production facilities, loss of access to raw materials as territory was lost, diversion of resources to competing priorities, and inefficiencies in organization and planning. But perhaps most fundamentally, Germany was fighting a coalition whose combined industrial capacity was several times larger than its own. The addition of American industrial might to the Allied cause in 1942 to 1943 made Axis defeat inevitable once that industrial capacity reached full mobilization. The paper drop tanks falling across Germany in 1944 to 1945 symbolized this industrial reality in a form so simple and so stark that its message could not be misunderstood. The examination of captured American equipment by German technical intelligence services had been systematic and professional throughout the war. Facilities like Reich maintained detailed records of performance, testing, material analysis, and technical assessments. These documents, many of which survived the war in various archives, provide valuable historical insight into how each side viewed the other's capabilities. German assessments of American equipment were generally accurate in technical terms. They correctly identified strengths and weaknesses of American aircraft, vehicles, and weapons. Where German analysis failed was not in understanding individual items, but in comprehending the scale of American production and the implications of that scale for the war's outcome. A single P-51 Mustang was a very good fighter aircraft. 10,000 P-51 Mustangs represented air superiority that no tactical skill or technical innovation could overcome. The story of German engineers examining paper drop tanks at Rechlin in March 1944 is ultimately a story about the nature of industrial warfare. It demonstrates that in conflicts between industrialized nations, production capacity becomes as important as battlefield prowess. The side that can build more, faster, and more efficiently holds advantages that tactical and operational excellence cannot fully compensate for. This lesson, learned at great cost by Germany and Japan in World War II, influenced military planning throughout the Cold War and continues to inform strategic thinking today. The ability to sustain production of advanced weapons systems, to maintain supply chains under stress, to train personnel faster than they are lost in combat, and to outproduce an opponent over extended periods remains as critical now as it was in 1944. The March 1944 missions to Berlin, the first to be escorted all the way by single-engine fighters, marked a decisive turning point in the air war over Europe. From that point forward, no target in Germany was beyond reach of American bombers with fighter escort. The systematic bombing campaign could proceed with losses that, while still significant, were sustainable. German war production came under increasing pressure. Synthetic fuel plants, ball-bearing factories, aircraft production facilities, and transportation networks all became targets that could be attacked repeatedly with fighter escort throughout missions. The cumulative effect of this campaign, combined with Soviet advances from the east and Allied advances from the west and south, brought about Germany's defeat 14 months after the first P-51s reached Berlin. The paper drop tanks served throughout this final period of war. Production continued through 1945, with thousands manufactured each month. The tanks were used not only by P-51 Mustangs, but also by P-47 Thunderbolts and P-38 Lightnings, extending the range of all American fighter types. British fighters also used paper tanks extensively. The Royal Air Force's Mustang squadrons employed them for long-range missions over occupied Europe and Germany. The efficiency of paper tank production freed aluminum and steel for other uses, while providing range extension necessary for strategic operations. This optimization of resources, matching production methods to requirements and prioritizing efficiency over tradition, exemplified the industrial approach that characterized Allied operations throughout the war. Today, Historians studying the air war over Europe recognize multiple factors that contributed to Allied victory. Numerical superiority in aircraft and pilots, technological advantages in areas like radar and communications, strategic bombing of German industry and infrastructure, and the cumulative effect of sustained combat operations that depleted German resources faster than they could be replaced. The P-51 Mustang and its paper-drop tanks were important elements in this multifaceted campaign, but not the sole decisive factor. The air war was won through combined efforts of multiple fighter types: bomber, forces, industrial production, pilot training, intelligence gathering, tactical innovation, and sustained commitment of resources. The paper-drop tank represents one component of this larger effort, notable because it so clearly symbolizes the industrial advantages that underlay Allied success. The technical files maintained at Reich documented American capabilities with professional precision. German engineers recorded specifications, performance data, construction methods, and production estimates with thoroughness characteristic of German technical work. These records, preserved in various archives, including the Bundesarchiv, provide historians with detailed contemporary assessments of Allied equipment as seen through German eyes. Reading these documents today with benefit of historical hindsight and access to American records reveals that German technical analysis was largely accurate. They correctly understood American capabilities. What they could not change was the strategic reality those capabilities represented. Understanding that an enemy possesses overwhelming advantages does not provide means to counter those advantages when they are rooted in fundamental disparities of industrial capacity and resource availability. The legacy of the paper-drop tank extends beyond its wartime use. It serves as a reminder that effective solutions need not be sophisticated or technically impressive. A tank made from glued paper, designed for single use, manufactured from non-critical materials, represented an appropriate solution to the specific problem of extending fighter range. It was good enough for the mission. This principle, designing solutions that are adequate for purpose rather than pursuing technical perfection, became a fundamental concept in modern systems engineering. The best solution is not always the most sophisticated. The best solution is the one that meets requirements while being manufacturable in quantities needed, within time available, use accessible resources. This lesson, taught by paper-drop tanks falling across Germany, remains relevant in military and civilian applications today. The aircraft that carried those drop tanks, the P-51 Mustang, stands as one of the most successful fighter designs in aviation history. Its combination of range, performance, reliability, and producibility made it an ideal escort fighter for the strategic bombing campaign. The Mustang's success resulted from multiple factors. The aerodynamically efficient airframe designed by North American Aviation's engineering team led by Edgar Schmood, the powerful and reliable Merlin engine, the addition of the fuselage fuel tank that extended range, and the availability of drop tanks that pushed operational radius beyond 800 miles. No single element created the Mustang's effectiveness. It was successful integration of all these components, supported by industrial capacity to produce them in quantity, that made the P-51 the decisive escort fighter of the European air war. 80 years after the events of March 1944, the lessons remain instructive. The examination of captured equipment by German engineers at Rechlin revealed not just technical details but strategic realities. The paper-drop tanks demonstrated that the United States possessed industrial capacity beyond Germany's ability to match, that American engineering emphasized practical solutions over technical perfectionism, and that the Allies had sufficient resources to optimize for efficiency rather than make desperate substitutions. These revelations, coming in March 1944 when the war's outcome was not yet certain but the trajectory was increasingly clear, provided German technical staff with clear understanding of the challenges they faced. That understanding could not change the outcome. Germany's defeat was determined by factors beyond the control of engineers at testing facilities, but the story of those Engineers examining paper cylinders of glued kraft paper, calculating fuel capacities, and recognizing implications for the air war provides insight into how industrial capacity determines the outcome of modern conflicts. The war ended in May 1945. The systematic bombing campaign enabled by long-range fighter escorts, including the P-51 Mustang, had contributed significantly to Germany's defeat. Industrial production had been disrupted. Transportation networks were devastated. Fuel supplies were exhausted. The Luftwaffe was reduced to a token force. These outcomes resulted from many factors operating over several years, but the ability to escort bombers throughout their missions over Germany, made possible by fighters like the P-51 carrying drop tanks, including those made from paper, was among the decisive elements. The paper drop tanks themselves, those that survived, became historical artifacts. A few found their way to museums. Most were destroyed or discarded. Their significance lies not in the objects themselves, but in what they represented. Industrial capacity applied with strategic purpose, appropriate technology solving specific problems, and the decisive advantage of overwhelming production capability in modern warfare. That story, preserved in technical reports from Reich and other archives, continues to inform understanding of World War II and the nature of industrial conflict. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.